Welcome back, everybody, and in this video we're going to be taking a look at the ASA MPF with the global policy connection limits, and we're going to be focusing on the timeouts and how they come in and work and operate. So let's go ahead and take a look at ASA 1, and we're going to do a show run timeout. Out. So by default we have a handful of timeout values that are predefined on the ASA. And in order for these to work, or in order for us to manipulate them, we have to understand what they are first and foremost and how we can tweak them and stuff like that. So as you can see, the first three are the ones we're going to be focusing on right here, which is going to be the XLate or the NAT translations. We have the port translations, which last for 30 seconds. And then we have just the regular old-fashioned connection timeout. So we have a normal connection lasts for 5 minutes. We have a half closed, lasts for 10 minutes. A UDP connection lasts for 2 minutes. A secure copy, or SCTP, I'm not sure exactly what that is, lasts for 2 minutes. And an ICMP connection lasts for a whopping 2 seconds. So it'd be Johnny on the spot when we go check those out. So if we wanted to manipulate these to a different variable, we could. Actually, this is not right. So actually, this value right here, if I was to do no and pull this out right here, so this value is an hour. That's an incorrect value. So let me do a clear configure timeout. Show run timeout. There we go. So it's supposed to be an hour, not 5 minutes. Sorry about that. So we have that value defined. So if we wanted to change the value from an hour to be something less, and normally I recommend doing something less because when you're labbing it up, you don't want to spend an hour waiting for a timeout or anything like that. So we could type in the timeout, and we can specify for connections is we specify a timeout. So the timeout value specifically means that the idle time after which a TCP connection state will be closed. What that specifically means is idle. Now, if you're actively working on the TCP connection, let's say you open up a telnet session from test 9 to test 12, and you're working on test 12 through test 9. If you're actively sending commands across that telnet session or SSH or whatever it might be, it is never going to idle out. But if I was to come over here to test 9 and do a telnet to 172.16.30 172.16.30.12, type in Rob and Cisco, and go back over to ASA 1, and then do a show con long for TCP for the protocol of TCP on port 23, you're going to see that I have an open connection to test 12, and the idle it's been idle for 18 seconds right there. Actually, I don't want to do that. I am in the way. So if you look, it's been idle for 18 seconds. Now it's been idle for 7 seconds. So there's communication going back and forth. If I was to go to test 9 and hit the enter key a couple times, go back over here, hit ASA, hit the up arrow, it's been idle for 4 seconds. So the longer it's idle means that the less time it's idle means the more active it is, which means the longer it's going to be in the connection table. And as you can see right now, the timeout for this connection right here is 1 hour. Now if I wanted to change that, I could, which is the timeout con, and then I could specify a value. So it says you can specify any value 050, which means 5 minutes. So hour, minute, and seconds is what this value comes out to be. So let's see if we can go 0, say 0:30. So it stays only active for 30 seconds. It says it won't take that command. The time should be at least 5 minutes. So we'll put in here a 0, pull this 0 out, put a 5 in place, and incomplete command. So we'll just say 0. So if we do a show run timeout now, we'll see that the connection now for any connection is now 5 minutes. So now if I go back over here to test the ASA and I hit the up arrow a couple times and go back to that output, now it's been idle for 15 seconds. So the uptime is a little over 2 minutes. If I was to just let this sit, it would keep going. But you'll notice that even though the idle time continues to increase, the timeout is only an hour still. So if I wanted the new timeout value to take effect, I actually had to clear the connection. So clear con and hit the enter key. So there's 2 connections. So I'm going to go back to this guy. We no longer have an active session for Telnet. I go back to test 9, hit the enter key. It says it was closed. So let's go ahead and retry that. Rob and Cisco. Go back to ASA 1, hit the up arrow. I have an active connection. Now the timeout is 5 minutes. So if I let this sit here for the next 5 minutes and don't do anything, it would eventually time out. If I didn't do anything, if the connection stayed idle. So I'm not going to make you guys wait 5 minutes. But if I was to go and do that and wait the 5 minutes, so what would end up happening is that the Telnet session would just terminate. Because once you go beyond the 5 minute window, it doesn't terminate right away. It takes a couple seconds for it to trigger. But once the timeout and the idle here has to go to 5 minutes. Not the uptime. The uptime could be 3 hours. But if the idle time goes to 5 minutes, it should be aged out. And so somehow it reset itself. I don't know. There's got to be some sort of communication going back and forth between test 9 and test 12 in order to reset that. And the uptime, what was the uptime before that? 28 seconds? 26 seconds? Okay, so the uptime is still trying to increase. We see the idle time is now 11 seconds, and it's starting to increase. Again, I'm not going to make you guys wait for that. There's a way to manipulate this, and this is the connection limit. So this is going to be just specifically for timeouts. If I wanted to change this, and let's say I don't want to. I don't know why it does that. It's got to be a hotkey associated with that. Okay. Yeah, let's say I don't care. I just want to allow the communication to go and go and go, and I could leave a Telnet session up all night, go home, leave it up, go home at the end of the day, come back in the next day, and the Telnet session is still there. How could I accomplish that? Well, you can. It's called what they refer to as dead connection detection. So we do a show run policy map. We go underneath the class of class dash default, and under here we can set the connection, and the timeout is going to be for we can set the idle connection if we wanted to, but we're going to set the DCD, the dead connection detection retrainable, and we're going to specify this as a certain value. So, which means that this is how often the connection is going to stay up, or is going to be attempted. By default, it's not enabled. It's disabled by or it says that the default is 15 seconds. And as far as I know, this is not enabled by default. But what I'm going to do is I'm going to choose a value of 0:0:5, so 5 seconds. And how often is it going to try? I'm going to say every 3 seconds. So I do that. Now if I do a show run policy map, come down to the bottom here, now I have a set connection timeout DCD to every 5 seconds. Now what's going to end up happening is the ASA will send a TCP probe to the source and destination, so the source, the server, and the client, with the acknowledgement bit set, in an attempt to send packets out to say, are you still alive? And if you get the acknowledgement back, that means that the connection is still up. So if I hit the up arrow a couple times and I go to this output right here, right now, I am going to have to reset the time. So I'm going to go ahead and clear con and hit the enter key. And then I'm going to go back to test 9. Try this again. Rob and Cisco. Go back to the ASA. Hit the up arrow. And it's going again. But here's the thing. There is no... the DCD timer doesn't show up. Right? There is no indication that there's any connection going on. And normally one thing that you could, if you have ACLs applied to the outside interfaces and you're blocking specific traffic, you would actually see the ACK coming in. It would be denied. But as it sits right now, what will end up happening is this particular communication will be sent outbound. And let me go ahead and close out. So that's still pinging. Forgot that was even on. That's going to continue to ping. Or I'm sorry, that's going to continue to keep the connection up and running. And if it happens to, if we do a show timeout, show connection timeout, so show time out, show run timeout, you'll see that when we look at this config, the DCD timer doesn't apply underneath here. If we do a show policy map, show service policy, global, and hit the enter key and go all the way down to the bottom, you will see that underneath the class-default, for any traffic that doesn't have a more specific inspection policy, we'll see that DCD is enabled and that it's going to send every 5 seconds for a maximum of 3 tries. If something happens in that time frame, it'll say, okay, the connection is no longer there, go ahead and kill it. But at this point here, we're in good shape. So if we do that same output again, now it's idle. It's idle again for 0 seconds, which means something happened and it triggered. So I don't know if it goes to a certain point and then the trigger goes off. Okay, there's 15 seconds, 19 seconds, 22 seconds, 25 seconds. As you can see, I'm continuing to hit the up arrow, and okay, there it went to idle. So every periodically, the connection will be maintained, and so this will go beyond the timeout window of 5 minutes because the idle never goes to that level. It never goes up that high. So that's how you deal with DCD. It'll keep the application up and running for pretty much as long as it is. Now, one thing that I think will happen is if we go on to test 12 and we come in here and we do a show run all pipe begin line VTY, there will come an upper limit on the VTY line where we have a exec timeout of 10 minutes. Now, my understanding, and I don't have a definitive answer to this, but when I was testing this out, the exec timeout sits at 10 minutes. So even though the TCP connection might be kept alive with dead connection detection or DCD, the exec timeout, there might not be any packets sent back and forth. So at the 10-minute time frame, the connection should expire and close the connection. So it won't be the TCP, the ASA closing the connection. It'll be the server or the client. In this case here, the server will close the connection because the timeout for an idle session died. Now, I don't know if there is if there's any truth to that, or that's just my interpretation. You can test that out if you'd like. But I do remember staying up for a while, and I was like, okay, because I have a when I did test this out, the uptime was over 10 minutes, and it was still up and running. So with DCD enabled, so the uptime for the connection was 10 minutes and 7 seconds, and it was still up and running. So it would have gone beyond that. Maybe at 11 minutes it closes out. I don't know, but just to be aware, that's what DCD does. Now, there's another thing we can do with what I refer to as simultaneous sessions. Simultaneous sessions are still configured underneath the class domain. So here we type in set, and then we have connection, and then we have the per client maximums, which is this, and then we have the per client embryonic maximums, and then we have the obviously the connection maximums, but that's a number of maximums for so when we say connection max, embryonic max are total. Doesn't matter how many people there are. We have the per client, and we have the per client embryonic, and we have the per client max. This would be this one here, the con max and the embryonic con max. Those are an aggregate of all sessions. So if I was to come in here and say set connection max for all flows to be, let's say, 200. And then I came in here and set the embryonic max to be 10. And then I set the connection for the per client max is 30. And I set the per client embryonic max to be the per client embryonic max to be 3. If I do a show run policy map, what you would see in a single line is you would see set connection max to 200. So 200 total connections can be created through this firewall total. Then on the embryonic connection maximum, I'm only going to allow 10 half open sessions. And I can say per client, I'm going to allow each client a maximum of 30 sessions through the firewall, not to exceed a total of 200. So what I normally would do is I would have to say, okay, if the per client max is 30 and I've got 5 users, that's going to be 150, I should be fine. So then the total wouldn't exceed 200. And then the per client embryonic max is 3, so they're variables of each other. So that would be something that I could do globally to configure what it is that I'm trying to accomplish to limit how many resources the ASA has to use. If I only have a handful of users, this might be something to do because the ASA will continue to open sessions up to its maximum resource capability. So whatever the CPU and RAM is of the firewall, it'll keep opening sessions and opening sessions until it physically can't open any more sessions based off of the maximum allowed, maximum capability. So I can do a show service policy global, and I think I can go to, no I can't, I have to go all the way to the bottom here. So what you're going to get, let me go to, I don't have that open anymore, but if I had any connections open, what you would see, and if I was to open up a couple of connections, you would see this number jump. So let me go do this. Let me go widen this out just a little bit. And actually, let me pull up server 2 again on B and C. And then let me go ahead and pull this guy up and out of the way a little bit and then move this over. See if I can get everything to be in line so it's easier to read. So let's go this again. Much better. So now what I can do is I can come in here and I can say, you know what, let's open up a web browser. Let's open up Firefox. And then on Firefox, we're going to go to msn.com. The likelihood of us finding a lot of sessions opened is possible. So what we'll be able to do is msn.com. So it'll take a couple seconds for it to figure it out. So it's reaching out. If we hit the up arrow and we type in pipe begin class dash default, we're going to see that there is current connections, there's 24. Current embryonic connections, there are 2. We come back over here and it's opening up, so we'll continue just to do this. So current embryonic is 2 and current connections is 28. You'll see drop is now 6. And it'll continue to climb. Drop is 20, current connections is 29. So the per client maximum is 30. So it can't exceed 30. So there we have 30 connections that are open, and we have 69 that are dropped because it exceeded the capability. So that would be something if we were to do a show log. I don't know if it's going to show us. There's usually a syslog message that's generated when we do this. Let me see here. I might have to clear log. Well, that's not what I wanted to do. Okay, that did kill it. So let's go ahead and say clear log, clear logging buffer, and let's go to and hit the up arrow a couple times, and so we have a lot of drops, and so it's clearly able to pull it up. So let's go to the Microsoft Store. Let's get a redirect. So it's going to go out and it's going to try to open up that connection. So now if we hit the up arrow, we have this, and if we try to go do show log, we should get, when there are sessions that are dropped, we should start to see them show up in here. And actually, logging is disabled. So let me exit out of here and type in logging enable, and logging console is 6, or let's do 4. Logging buffered is 7. So let's do a show log again. So we'll see that the connection should be, once it goes above the maximum, it should be, yeah, see right here, per client connection limit time exceeded 30 for 30. And for this. So it's trying to open up the session, but it can't because the per client maximum has been reached. You wouldn't think that 30 would be too many. You would think, oh, that should be right up my alley. And in reality, that's not. It's actually too much. So that's how you set the per connection maximums there as well if you'd like to do that. And you can come in here and you can do the show. So there's 467 drops. There's currently 18 connections open. Pretty good stuff. So the last thing I'm going to show you in the global policy before we dive into some of the more advanced inspection capabilities is going to be things like traceroute and stuff like that. So we're just going to go ahead and close this out because I don't want to waste the resources if I don't need to. I'm going to come in here and I'm going to say command prompt. And if I wanted to traceroute to, let's say I can ping Google. Well, actually, let's keep it internal in the network. So 10.255.1.1. I can ping one of the IP addresses on my home router, which means end-to-end connectivity between me and where I want to go is there. Now, if I try to do a trace route to 10.255.1.1-D, so I don't want to look up DNS names. Now we come in here, notice where it says deny ICMP source of 200-1.10.1 by access group permit. So what's actually happening here, code 11, so we're denying ICMP, right? But what's actually happening is the traffic that's leaving the firewall, leaving the server going out to the internet is, and you'll notice that the IP address changed. It went from 200-1.10.1 to 10.1.1.1. So what's happening is, on a per hop basis, the connections are going out UDP as a trace route. And there are ICMP unreachable and ICMP time exceeded messages coming back for every hop that the trace route goes through. So as they're going through the nodes on their way to the destination, all of these connections are going out. There's different type codes, and here we have type 11 code 0 are going out and then coming back. So it's UDP out, ICMP back in. Because of that, because we're sending out, and if I was to do a show con long, we don't have any at the moment, but if I was to come in here and hit the up arrow and try to do that again, notice how the 10.255 1.1 responded. We try to do the trace again, but if we hit the up arrow and try to do con long, we're going to see ICMP outside. We're trying to send the traffic out. I'm not catching it fast enough. So what I have to do in order to fix this is I have to allow ICMP unreachables and ICMP time exceeded messages back in order for this to take effect. So let's go ahead and do that. So we're going to do a access list. I'm going to say, in this case here is going to be ACL, type in ICMP trace inbound, and I'm going to type in extended permit ICMP any unreachable, and show run access list. Oh, I forgot that I already had it configured. So this ACL has to allow the communication outbound, right? If we do a show run access group, well, we don't have any, so we're going to do a show no. Let's go ahead and pull this off. So because we're not permitting the ICMP back in, the ACL is dropping it. So we have to type in access group and ACL ICMP trace in interface outside. Now if I go back to here and I try to do that trace again, the trace does work, right? And so we see the 200.1.10.1, 10.1.1.1, and 10.255 1.1. But the problem with this is if we do a IP config, what is my default gateway IP? It's 172.16.30.1, right? What don't I see in the trace? I don't see my IP address. And the reason why I don't see my IP address is because the ASA by default does not participate in the TTL decrement on a per hop basis. So if the routers do by default, they say, oh, you want to trace route through me? Sure, I'll respond to your ICMP messages, and I'll even decrement my TTL for you because it's per node that it's going through. So as far as ASA, or I'm sorry, as far as server 2 knows, its first hop is actually 200-1.10.1 from a path perspective, which actually is not true. So to fix this, we have to go to show run policy map again, and we have to go underneath the class-default. So I'm going to come in here and I'm going to go to class and class-default, and I'm going to say set the connection to be decrement TTL and hit the enter key. Now we'll retry that trace route again and see what happens. And we'll see that 172.16.30.1 shows up, and so my trace route is now end-to-end. I'm including the ASA in the trace route, and everything is good to go now. So that's basically what ends up happening. So that is why when we see issues like that, that's what needs to happen. So that's pretty much it for what I wanted to show you here. And if I wanted to do a show service policy global pipe begin class-default, we would see this. We have the embryonics configured. We have the set connection policy for DCD set. The connection decrement DTL is defined. All that stuff is working. And we've been able to demonstrate each part of it. If we do a show access list, we see that on the ACL trace in, that we have multiple hits on it, and everything is working the way that it's supposed to. Now, we've already talked about NAT, so I'm not going to spend any time on NAT and explain what's happening there. But as it sits right now, everything's working. So until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video. Take it easy.